Hello everyone again. Welcome to lesson 3, which is going to be our lesson on equation manipulation. And when we're talking about equation manipulation, the couple things we need to remember. Number one is the term equation. That gets our word equality back into this lesson, and we've talked about how algebra is the quest for equality. So when we're in this equation manipulation lesson here, we're looking to maintain equality while changing the appearance of the equation. So we're kind of making it look the way we want while making sure we maintain equality and following all of our algebra rules. And even though we have Einstein here on the first page, don't worry, it's not going to be all of that difficult. One of the more famous versions of equation manipulation takes us way back to ancient Egypt, where, as you can see our picture of our Egyptians here, they had a lot of mathematicians back then, and they had a lot of rudimentary tools. They didn't have a lot of great measuring tools. And they were the first people to make our discovery of pi, where they made the discovery that no matter what the size of a circle is, you can measure the circumference, the distance around the outside, and you can measure the diameter. And they found that there's a common ratio there, that the circumference divided by the diameter of a circle was always around 3. And like I said, they had some pretty rudimentary measuring tools, so their measurements were pretty poor. That's why they ended up with a value just around 3. But now today we can get into, much more specific values where we can get to 3.14, 159, all those numbers that you may have memorized at some point. But we all know pi is a continuing value that goes on forever without ever repeating. It's an irrational number. And so therefore what we've come to use this for is we've discovered that pi is actually a constant value. We know what pi is. It is a measurable, it is a constant value. So therefore an equation of pi equals circumference divided by diameter isn't necessarily helpful to us. What would be more helpful would be to have a formula that tells us how to find circumference, because diameter is a straight line measurement. That's something easy to measure. Pi is a constant value, so we can use that in our formula, but it really doesn't help us to have a formula for pi. So therefore we've done what's called some equation manipulation. And in this case, in order to get circumference, we have to solve for the letter c. So we take our formula and we look at it and we see we have c divided by d equals pi. So therefore if we want to solve for c, we need to get rid of divided by d. So therefore we multiply both sides by diameter, giving us circumference equals pi times diameter. That's a very, very basic version of equation manipulation, where we were presented with information in one way, we wanted to change it or manipulate it so that it looked the way we want. But in order to do that, we have to make sure we use our algebra rules to maintain equality. Alright, so let's look at a few more examples and a couple more difficult ones as we go here. Our first example is a common equation, y equals mx plus b. We use that all the time. You're very comfortable with that. But we might want to look at, what if we wanted our linear equation solved for x? What would we have to do? Well, for a lot of you, this is going to be a very natural process to use the linear equation stuff we know from our previous units to simply say, well, if I want to get x by itself, I have to get rid of plus b. So therefore, I minus b to both sides, which leads us to y minus b equals m times x. When we have that, some of you are really going to like this because there's no calculation involved in these manipulating equations. We don't have to subtract y minus b because we can't do that. We simply leave it as y minus b. So in other words, we've basically just moved the b to the other side of the equation. Then, in order to get the x by itself, we have to divide by m. And again, because they're letters, we can't do y minus b divided by m, so we simply leave it in that format. The one thing you do need to be careful of is anytime you multiply or divide on both sides of an equation, you need to make sure you're doing it to the entire side of the equation. And that's why y minus b is grouped together on top of the division bar. We need to make sure we maintain that order of operations. And so we have to keep y minus b grouped together with all of it being divided by m. Alright, our second example, where we have a divided by x equals c, and we want to solve for x. This is one that I've found people have a lot of trouble with. When the x appears on the bottom of an equation, or when you have a divided by x equals c, because we don't have a direct method to get rid of the a. That's how we've always done things, is get rid of what's with the x. Well, in this case, we have to multiply both sides by x in order to get rid of it on the left side and move it to the right side, so we end up with a equals c times x. Now we have something that we should be familiar with and able to solve quite easily, where in order to solve this, all we have to do is divide both sides by c, giving us x equals a divided by c. Our final example is going to be one that has a little bit higher level of difficulty, a little more challenge to this question. For example 3, we're looking at an equation that says px plus cx equals ab, and we're asked to solve for x. The first step is the most difficult one, because when you look at that equation, you look at that and you say, I can't put p and c together. Normally, those would be like terms. They're both x terms, so I could put those together. With variables, we can't do that. We can't put px plus cx together, so we have to go back to the end of Algebra 1 and some of the things we might remember from there. If something appears in both terms, we can use our knowledge of the distributive property and factoring to say, I can undistribute or factor an x out of both of those terms. So therefore, we're left with x times the quantity p plus c equals ab. Finally, to solve that, we need to divide by the quantity p plus c. That leaves us with x by itself, and we have x equals ab over p plus c. And again, we have that grouping of the division bar where p plus c is in parentheses on the left side, creating a multiplication situation of x times p plus c, which allows us to divide by that quantity. However, on the right side, when you get to your final answer, the parentheses are unnecessary because that division bar assumes there is a parenthesis. You do everything on top and everything on bottom. So that leaves us with our final answer of x equals ab divided by the quantity p plus c. So this is equation manipulation. That's what we're talking about. We're just taking a formula and changing it around to look the way we would like it to. So hopefully this is clear to you, and if you have any questions, please write them down. I hope you have a great weekend, and we'll see you on Monday.